Bit of a lag there on your sound.
That was like I tapped on it on my phone and it started playing. So hello to everybody. And I assume there's a whole bunch of people that have done exactly what I did. You get the notification that AWS went live. You tap on it and you see what's happening today. So what's happening today and right now is devs in the shed. So welcome to all of our audience and welcome back to Aaron and Matt today.
Thanks,
It's
Paul.
Yeah, it's I think it's been it's the hectic time of the year for anybody that's heavily invested in AWS, and especially for us as employees of AWS or solution architects at AWS, because obviously in 15 days, less than 15 days, what is it, like 12 days or something to the actual event, reInvent is kicking off. So we are all preparing that, busy up in the morning, communicating with our international teams around our workshops and presentations, and trying to organize like where we'll be, and which sessions like our customers might want to go to and what might be interesting to them. And so it has been a busy period of time, which has been pretty exciting. And yeah, like it'd be interesting to hear from the audience today if anybody is planning to go to reInvent. Again, like Matt, myself, and Aaron will be there, and we have a live stream that we have been preparing for, and we've built out a fun, interactive application, and we'll probably talk or touch on that a little bit next week, or what it might be, a little couple of hints. But interesting that we have got custom gear to wear on the day. So we're trying to do the artwork for that and put some things together so that people can be like interactive with the, what we're planning to demo on the day. But, so yeah, so welcome Matt and Aaron. I'll asked an interesting question here, and maybe this is an interesting one because I was watching another video from an ex-AWS employee, Lucy, and she runs a stream called Tech with Lucy. And it was just interesting watching a lot of the questions that she gets. So Alvi asks, are we from a computer science or is someone self-taught? Like I personally did a Bachelor of Computer Science, and that was 20 years ago. I completed that. And Aaron, I know you did, but Matt, I'm not sure whether you completed like a full university, did you?
No, there wasn't a need to, was there? So I mean, the funny thing is, like, yeah, I am completely self-taught when it comes to computer science. In some respects, put me a little bit behind the game because computer science teaches you really important fundamentals. I actually studied video game design at university, so I had touched a little bit of programming. I'd done my own scripting for video games, dealt with like very high level languages like Lua, and done like simple programming in C. But my focus was actually on the level design and making 3D models. And I thought I was actually going to go into a video game company. And then we had the GFC hit. And so I pivoted, became self-taught as an iOS programmer, and moved into an industry that way. And I've had to go back and then study elements of computing science to kind of end up in the engineering role that I'm in at the moment. Yeah.
I would say if there's some context behind the question, if I can guess at the context, if you're young and you're getting into coding, I would say there is no need to have a full education in computer science to get into coding nowadays. Yes, I do have a educational background, but at the same time, I reckon Paul would agree that like a lot of what we do is self-taught as well. Like we may have 20 years ago had our education, but a lot changes in 20 years, and like you self-teach the things you're interested in. So I can't remember the last time I actually used a language or used a concept that I learned at uni in today's technology, like the stuff that we do today. So if you're getting into tech, if you're getting into cloud, if you're getting into programming, self-taught nowadays is just as good as having an educational background, depending on like where you want to get into. To Matt's point, like, yeah, you might have to go and do a short course, or go and learn about a specific subject matter, to get some depth in that area. but you can still pick up a lot of the general skills that you need to get into programming and tech. That you if you've got the interest and passion to get in and like build and don't be afraid to fail and make mistakes and blow stuff up.
The most important thing is code every day, right?
Talk to us about Big O. Like we'd like to understand Big O and how that applies.
Big O notation. Do we really need to talk about Big O notation?
Yeah. See, the one that doesn't go. Yeah, there we go. So yeah, I think it's a mix and a match case of what it comes to. So today we've got a session on building and diving into CDK that'll be led by Aaron today. But there was a couple of like little announcements that I thought were worth just calling out. So we're probably going to see some really good announcements in the next few weeks, and we've probably seen like a lot of announcements coming out, but we're probably going to see some really big ones in the next few weeks. But I thought there was just two specific ones that I thought were useful. So the first one I'll go, which is really quickly, which is AWS RDS SQL Server supports linked server to Oracle DB. Now, if you have used SQL Server, the ability to do a linked server in SQL Server Management Studio is like, it's a pretty useful tool, especially when you're doing some comparisons. You're moving through a migration stage, whether that be from one database to another or one engine to another. It enables you within SQL Server Management Studio to directly connect and query a different database on a potentially a completely different server, and in this case, completely different database engine. So you can query directly from Oracle and make those queries directly from Oracle and do inserts across into SQL Server. That might be really useful when you're going through preparation, the manual checks, becoming ready to do a migration step. If you're going to look at a full migration, DMS might be a better option for that. But specific like queries or databases or tables that require a little more finesse around what they're doing, it's often not as simple as just pointing a database and saying, hey, migrate my whole schema and data across from one engine to another. But being able to do that ad hoc and query those between the two, I think that's a useful feature there. And the second one was, it is sort of mentioned here, but it was much more around the ability to now deploy .NET 7 applications on AWS Lambda. Now, I couldn't see the exact release here. There's another actual blog post that comes out. Maybe Aaron or Matt can pick that up really quick and paste it into the chat. But we've seen, I can remember all the way back where I was working in a software company where we were building everything in .NET. At the time, .NET Core was becoming the preferred way and becoming prevalent. But at the time, then you had to use a custom runtime to be able to do .NET. It was really difficult. You had to layer it on top of one of the other instances and bootstrap it. It was really hard work. Since then, we've seen the evolution of .NET running within Lambda, and it's become easier and easier each time. If you're familiar with Visual Studio, you can deploy directly from Visual Studio. Otherwise, you can use SAM. There's a whole bunch of assistance around doing that. I know Aaron's done a specific video stream on Devs in the Shed around deploying .NET applications. But we see now that .NET 7 has a container that is available for you to use on your Lambda application. So this is a Lambda supported .NET 7 container. But there is no custom runtime to instantly deploy your .NET 7, no managed runtime for .NET 7 applications. And the reason that is because version 7 is not an LTS version of, so not a long-term support version of .NET. So that's why they've decided not to do that and just release the container. You can still deploy that and use your own custom runtime and package it up if you don't want to use the container-based ways. So I thought that was a good call out. What's becoming more and more prevalent with .NET, and some of these features were enabled earlier in .NET 6 and earlier, was some of these ideas to do like enhance the use of the just-in-time compilation. So you would be able to get additional performance insights, and we can see here. So and it's called AOT to do that. At native AOT enabled applications demonstrated an average of 44% and up to 86% improvement in cold start times. So, the number one feature request and ask around anything to do with Lambda is cold start. And we see that especially with .NET and Java. So those were the two announcements I wanted to bring up today. Unless there's anything
I had one. Yeah, I had one. So I do a lot of event-driven systems. I guess everyone at AWS does a lot of event-driven systems. So this one's probably a call out that I favor in terms of Event Bridge now supporting more advanced filtering. So that's the ability to filter on suffix filtering, so that at the end of the value equals ignore case. So you can actually ignore case, whether it's up or lower. But my all-time favorite one is or matching. So now you can actually have a single rule that will execute based on if any of a series of rules match. So it's this or this or this or this. So that's a really powerful one, which actually a lot of the logic that we end up writing in, say, downstream services are handling sort of the end result of the conditions, so the actual condition rule handling. So it gets rid of a lot of that additional rule handling that you need to do it in the service itself, and allows you now to do the or handling within the actual filtering within, or the rules within EventBridge. So that one for me is pretty exciting, and that was just released on Monday, so I haven't even had a chance to get in and play with it yet.
Very cool. I love EventBridge as a service. Like it's fantastic, right? Like you can basically have jobs that run on a consistent basis set up using CloudWatch events behind the scene as well. So it's really good for data analytics workloads where you need to follow a series of rules and process the data. You can tie it into step functions to make that even cooler. And then, like, some of the stuff that I've been using it for as well is basically to make sure that jobs run consistently when new data needs to be fetched also. So it's something that you can drop into kind of any kind of like pattern that you've got for your infrastructure around a particular application or workload, and you'll find a use for it.
Yeah, absolutely. It actually has made it a lot easier from the days of when we only had CloudWatch events. So now we actually have an interface for doing a little bit more advanced event choreography or orchestration.
Well, the rumor has it that it's built on CloudWatch events, right?
Well,
I don't think the documentation.
I'm pretty sure it's the same thing.
A lot of that.
It's just a UI for it, right?
Yeah.
Just been pulled out of CloudWatch.
So let's get into CDK, Aaron.
Yeah, cool. So I actually wanted to talk a little bit about mechanisms today, or like automation mechanisms. I'm sure a lot of you in the audience, who are developing distributed systems, and especially like getting into SaaS-based applications. So when you're trying to develop a multi-tenancy based application where you want to handle different resources, or you want to handle different users, or the different, whatever it is that's in your application that you want to create specifically for a tenant, as opposed to just the shared resources. That's sort of one of the mechanisms that I've been playing with recently. But I'd be keen to hear if anyone in the channel has any like automation mechanisms that they've been working on, or have any ideas around things that they want to solve in terms of when developing distributed systems. How are we, like, DevOps solves a lot of the deployment issues around, here's an app, we want to get it from app development into host, and there's all the things we go through in terms of testing and staging and everything. That's an automation mechanism, right? But then we're talking about solving problems for control, right? When we actually want to interact with applications and interact with, in this case, a multi-tenancy resource. So my resources, not somebody else's resources. Just like when I log into my Gmail, I'm reading my emails and not somebody else's emails. Like if anyone has like ideas around automation mechanisms, I'd love to talk about what you've got. But I'll jump into essentially, I'll give you a diagram first of what I'm talking about. So in this respect, I have been working on a project that requires the stand up of a specific service segregated resources. So in this case, we have a resource stack per tenant. So every tenant has their own Cognito user pool. So the user pool is used to authenticate that specific tenant's users. An administrator for that tenant can get in and set up all the users for authentication. There is an S3 bucket, so the storage of all of that specific tenant's objects that they're storing in this application. and then a DynamoDB for metadata, so the management of data for the actual application itself. Then I've just shown a very simple snapshot down the bottom here of the SaaS app. There's a lot more going on, down the bottom here that is I'm not showing because it's sort of irrelevant to the mechanism. But the key theme that I want to show here is that we've worked a lot with and we've done streams throughout the year with CDK, right? We've demonstrated developing a front end application and how to deploy it and host it. We had a guest come in and show us an amazingly complex simplification with CDK to go and deploy a WordPress application, including the backend database, the administration stack, the app stack, all through one single CDK app, and then deploying it out. This mechanism starts to get into the realm of now we're actually talking to multiple apps. So if you look at the top here, this tenant control app is one app that actually belongs to an ecosystem of apps that make up the entire SaaS platform. So in this respect, I've got my SaaS app here to demonstrate to you, this is stored or deployed outside of my mechanism. So these essentially would be existing resources in the account that I'm deploying into. The project that I'm currently working on actually has a lot more. So it has multiple CDK apps, which are deploying different stacks for different use cases within that account. And then so how do we interact? How do we deploy? And in this case, how can we simplify the creation of those tenant resources every time we sign up and get a new tenant? Because we don't want to be having to go and create a new stack or a new CDK app every time we want to deploy the tenant resources. But equally, we don't want to be going and creating a full CDK pipeline for every time we deploy those same single tenant resources. So quickly stepping you through before I jump into the code and show you what I've done. Essentially, I know I've demonstrated it a few times. I did my backend for front end pattern, getting in and doing some really complex actual CDK pipelines. This one, I promise you, is very simple. There's no major complexity other than the way that I'm deploying the actual the resource stack. It's simple, but it's non-standard CDK pipeline. We'll get to that in a sec. But anyway, so as you all know, when working with CDK pipelines, not just the code pipeline, we have a mutate step, right? So the first thing we want to do when we execute our code base, so the entire app, is go and synthesize and mutate any changes to the actual pipeline itself, and then go and create our artifacts for the rest of whether it's the control plane, whether it's the resources, and have those artifacts there ready to go and deploy. And that's an important call out here, because essentially there's two ways of doing a CDK deploy, right? Especially if we're doing a code commit trigger, is we can pull down that code every time and then do the build and do the deploy. But let's just say if we want to manage multiple commits per day into the code commit, and say I commit something that fails, I still want to be able to make a query to my control stack to deploy a previous artifact, which is the resource stack, to the existing environment, without having a breaking change that's been pushed through to the code commit affect my actual resource stack. And so for that, instead of pulling directly from the code every time, once we've done our synthesize and we've created those artifacts, what I've done here is when I want to redeploy just the tenant resources, I have my control stack is just a very simple API, which is talking to a Lambda, and that Lambda is just talking directly to the build server. So instead of talking to the entire pipeline and saying, let's trigger another pipeline and go and pull the code source and go and do the synth and everything, what we want to do is we want to rely on the pipeline will reject any breaking code change that's come through the code commit. So we know that if I call the downstream build server that is just to deploy my my tenant stack, then it's the artifact there is already what do you call it, built and stored on a working code base. So essentially what we do here is the control stack, as I said, it's an API, talks to the Lambda. The Lambda triggers directly a build on that build server. Now, if you're used to working in the console, this can get a little bit confusing, because when you're actually in pipelines, you'll actually see the build server running that's been triggered by the pipeline. If you trigger a build server that is in a pipeline, but directly, and then you go to the pipeline, it's not going to show you that it's currently running because it's not linked to the current pipeline. It's a standalone parallel execution of the build.
Bless you, Paul. I just sneezed as well. But it's like, for context, we're supposed to be in summer in Melbourne, and it's like we've had floods and rain and hail.
It's just started raining again outside. I can hear it.
And there's all this pollen that's up in the air as well. So I sneezed. If you watched, I did it on mute. Like, I don't know if anyone in the audience saw.
No, that's what I was going to say. I was going to say nice, quick mute there, Paul. like Matt did.
Sorry about that. So like it's just hay fever. We're all good to travel next week.
Yeah, I'm not leaving the house until I leave. I don't want to catch COVID. Okay, where was I? All right, so my Lambda triggers a build server. That build server is picking up the artifact from a previous successful pipeline build, and then it's going to go out and do the same as it would with a the pipeline deploy, except all it's doing is it's triggering the resources. Now, the important thing to remember is in a pipeline such as a CDK pipeline here, the artifact that we're building here isn't actually the synthesized resources. So if you're familiar with doing CDK in the command line, you can do CDK synth, and that'll create your CloudFormation templates. And you can do CDK deploy, which also does the synth first to the templates and then pushes those templates into S3 and triggers CloudFormation to go and pull them and deploy them. When we're doing a pipeline like this, the reason we have the synth step is because we actually need to go and synthesize that code source, because the artifact that gets pulled is actually it's a zip of the code source. So it's the entire code source. So you can actually set up additional build steps to go and do something different with that code source. So if you recall a few episodes back, we did the back end for front end. I was actually doing another a front end build after deploying some back end resources to take the AppSync URL and the API key and add them to the front end application, and then build the front end application and then deploy the front end application. So you can do a few fancy things with the build servers, because the artifact that build server receives is the zip of the code source. Now you can specify an output artifact as well if you just want to take that synthesis, but in this case I don't. I just want the last known successful code source. And then essentially all that tenant build source is doing, this is one of my favorite ways of linking together multiple stacks. Obviously, there is, or I should say, multiple apps or stacks within an ecosystem. There is methods within CDK. So like in my CDK app, I'll show you soon, I can call the existing query of an existing resource, right? So I can say, hey, there's an API gateway already in the account, go and get it by name or go and get it by ID. And we want to do something. We want to interact with that resource. So we don't have to be creating new resources every time we're running a CDK stack, right? Or deploying a change set. In this case, I'm querying in an existing resource. I'm creating a API key. I'm even actually creating a usage policy, but again, usage policy, not important for the rest of the application, for this mechanism, but for the application, it's helping me track all of the queries that are coming from the front-end application through the SaaS application. So once I've created that API key, I then take that API key, I go and create my individual resources. So simple, normal as you would in any CDK app, go and do a new instance of Cognito, a new S3 bucket, apply your security policies to it, your DynamoDB. And then the additional thing that we need to do here is be aware that there's a role that's going to that needs access from the lambdas that are going to execute across those. So we just add a little bit of an extra security policy to allow existing lambdas in the account to execute on those new resources that we've created. So we update their policies to allow those, and then we take the ARN for each of those resources and the API key, and we drop it in to the SSM parameter store. So now I have a key for each resource, which would be something like the name of my app, tenant / API key. So the API key is used as the key, not the value of the actual SSM parameter. And then I may even have a /name if I want to have like a human readable name for that, which will have the tenant's name, or if it's an organization or a user. But what I want from that is I'll have a table, and that'll be my DynamoDB table on the value. I'll have a /bucket after the API key, and the value of that will be the bucket on. And obviously you can figure from deduction that I'm going to do the same thing with Cognito. Then all I'm doing is, so that parameter store, obviously parameter store is not a service that you need to deploy instances of. Parameter store exists already in SSM, so you've got access to it across your workloads or across the resources that you're deploying into your account. So the lambdas that we have in the other app stack are reading from that parameter store based on the query of the API key that we've added, right? So when the front end application is querying the API, it's going to have the API key header. And so every one of the functions that fire off a request for resources, the first thing it's going to do is take that API key header, look up the value for each of the resources it needs to talk to, and then it has the ARN. So now it's going to go and, using the SDK, create the client, talk to the service or the instance by ARN, and then go and do exactly what you need to do. So if we're updating a record, go and do your query and update, or your update expression. So you're doing a one-time write credit across a read and a write. If we're reading objects from the bucket, or if we're writing objects to the bucket, and especially our Lambda authorizer. So the very first step is when we hit the API key for the first, hit the API for the first time with the key, we're actually handing it off to a Lambda authorizer, which is then going and talking to Cognito. So instead of doing the direct Cognito integration with API key, we hand it to a Lambda authorizer that takes that key, and then it does what the normal Cognito direct integration would do, but it's now knows which instance of Cognito to talk to based on the ARN, based on the resource identifier that we've stored in parameter store. So the rest of the SaaS application is unimportant, because that could be your whatever application you want to design, right? Before I jump into the code, do you guys want to add anything or question any decisions that I made?
It's very pretty architecture, Aaron. How do we convert the architecture into actual CDK, right?
I wanted to ask one more question before we go across to that. So obviously we're saying, like, as a consumer on a multi-tenant application, how do I ensure like proper tenancy with the resources that I'm interacting with, right? At the back end. So rather than your code saying, like, and I'm sure all developers have done this in the past, like based on, like, I don't know, something like a subdomain or something that determines that I am like customer X, and therefore customer X uses a table that's prefixed with customer X in my database, or an instance I've done before. Customer X is an instance of the database on the database server that is for customer X, so that you can't have bleed through or leak between customers, right? Obviously this is going to like incur a lot of interactions with parameter store. And that's what I was quickly sort of looking up, like what is the throughput the parameter store can handle for this? And like that would be my, I'm just purely interested, and I'll think about this immediately. Like, what would the cost be for me to like get and put something as a key value store in parameter store, like on every single request every single time? Like would we be throttled by that? So I'm just interested.
the actual parameter store, like general parameters, doesn't cost anything. It's free to do the query to general parameters. Now, you can have advanced parameters. That's something different, right? But for general parameters, and that's what I'm using here, there is no cost associated to just doing a quick get of the parameter to then use that to query my resources, right? The other question is a really good question. I am looking that up in the background now. In terms of the throughput, I haven't met any issues yet in terms of the time it takes to query. It's instant. I haven't done any actual benchmarking yet, which might be a good idea. I'll do that. I'm still working through the I don't know what you mean by Z, but I'm still working through the
Z is the paste error, right? Like Z is paste error. I was just looking through, like, so I was just checking the throughput, and like the reason this like is, you know, spiked interest with me right now is I was performing a well architecture review with one of my customers this morning, and one of the questions as you work through well architecture review is, are your teams that are developing and consuming services aware of API like throughput and resource limits for exactly this reason? So if you have a scaling event, and maybe you've thought about scaling in a way that says, my Kubernetes pods will scale from 100 pods to 1 million pods, right? And that's fine, like your compute can scale up, but have you thought about what will happen behind the scenes if each time you're hitting something like Secrets Manager or Parameter Store and you're not caching those parameters? How does that work, and are you aware of that? I just pasted the docs to talk about throughput, and you can request inputs for throughput. And like, we don't need to answer it now, but I think it's just something that is good to be aware of, that some of these services you can't don't just blindly use them without looking through the docs and saying, look, it's cloud, it's scalable. That's, you know, correct for the most part, but also be aware of like usage limits around APIs. And the direct response back to the customer is like, be aware of these things and look at what is going, so you can benchmark. But also when you are looking to test and determine whether your breakages are, Fault Injection Simulator can artificially throttle API requests. So therefore, you can determine what happens to your app when you no longer have access to something like Parameter Store over the APIs.
Yep. Absolutely. Also, just to the Fault Injection Simulator, recently network throttling was just released as well. So you can do traffic throttling across both APIs and the network, depending on whether you're running, let's say, a VPC, like you've got a container, or a VM, so an EC2 instance talking to an RDS, right? Now you might want to throttle the network to see if you're querying the key store, you know, as the secrets manager, to get the username and password to access the database. That is another great, that's the same sort of scenario that Paul's talking about there. To answer in terms of anyone who might be thinking, hey, why don't I just use DynamoDB? Because at the end of the day, DynamoDB is a key value data store, is because, one, I do require read units every time I make a request to DynamoDB. So if I'm having millions of requests to get different resource ARNs from my resource stack, then I'm going to start to accumulate read credits. So the idea here was to the actual mechanism that we're trying to create is a control mechanism that isn't what you would call like your general usage, right? So the general usage is when I hit my API. So I'm going to get my usage for hitting the API, the actual time it takes to execute the Lambda. All of these things are general or standard usage. So we don't want to have to say, all right, now we have to also account for how are we getting the resource identifier that we want to talk to. So just trying to minimize or cost optimize. Again, that's another well-architected pillar, is the cost optimization side of things. And to Paul's point, again, there are many ways of doing the very same thing, you know. So that was the rationale behind why we went with Parameter Store over something like DynamoDB. There are other ways
to interact with CDK, right? Like if you're doing this through a pipeline and you needed to put it into Dynamo, you need a custom resource, just extra work all the way through.
I'm going to show you that, and that's exactly why I wanted to show you this mechanism today, because Parameter Store through CDK is so easy to use. And I see a lot of people or a lot of customers, when developing, you know, getting their head around CDK and developing their apps, they actually start to use something like DynamoDB and different data store types using the SDK inside of the CDK. So they're actually making client queries to go and get some data to go and use it in their application when they're creating their stack. So synthesizing the stack and then deploying it. Whereas for simple key value pairs or simple key values in this case, and also parameter store does handle lists as well. So you can get a list type as well. For simple key value pairs and lists, there's no need to have a instance of a data store that's going to require setting up additional logic to do a client to set up the client and then query it and then get the data, because CDK inherently handles the writing to parameter store using the same way that it works with the synthesis of the ARNs and resource names and everything in the CloudFormation templates. So it uses the actual tokenization. So when it's going and deploying, it drops the token, and then depending on when the resource gets created, it'll then take the resource identifier and replace the token. So it knows to go and update the token with the value. And you'll see that when you sometimes get in and start synthesizing your templates, when you're actually handing values between stacks around, you'll find that, hey, I've synthesized something here and I was expecting a value, but actually I got a token. So that's sort of where the tokens come from. It's the ability to resolve a resource that maybe comes later after the logic has gone and created the parameter store item. So I'll in a very quick moment, I'll jump in and show you how I'm doing that. But essentially, parameter store here is the glue that holds together all of the different stacks within different apps within the same account. So that's the kind of the thank you for pointing it out, Paul, because that was kind of one of the key takeaways that I wanted for this session. The other one was obviously the ability to trigger a build server from Lambda. So that's not always apparent. A lot of people come to me and ask, I want to, simplify how I'm deploying an application. I've got this massive big code source, and we're doing multiple. Yeah, you did sidetrack me, but that's okay. We're doing multiple big. I'm used to following rabbit holes because sometimes when you get to the bottom of the rabbit hole, it was more fun than the original discussion. The other one was so breaking down massive big code source into, I just want to deploy these small blocks, and actually experimenting with, when you're doing a standard CDK pipeline, you create a single build and then you add stages. So it's basically I've built that build server is doing the mutate, so it's updating your pipeline, any changes to the pipeline, which also includes understanding what stages or what additional stacks that you've created as a stage it needs to go and deploy. That all comes off the one build server. So that one build server is going and synthesizing everything in your CDK app, and then it's going through each stage and saying, all right, well, this is the first one I need to deploy. It goes and hands off the template to CloudFormation, CloudFormation, and it runs and deploys it. And then it takes any outputs from that. If you're handing outputs between stages, it'll take the outputs and hand them into the next stage, and it'll go and deploy the next one. So the variation from a standard CDK pipeline is actually setting up additional build server steps. So you don't have to go, okay, one build server, stage. I go one build server, only synthesize the pipeline part of the stack. I don't have part of the app. I only want the pipeline stack. I don't have to synthesize everything when I do my mutate, because all the mutate is doing is really looking at your actual pipeline stack. The benefit of doing that is then I can go and synthesize, or like I said before, with the back end for front end, add changes to the code source or configuration or files manipulation, and then go and do a front end build or another back end deploy. Or there's always fun ways of handing around parameters and data between build servers. There's a lot of fun things that we can experiment there. So I'll quickly jump into the Lambda and show you that. But before I jump over to those two, I will show you exactly. I could have, had it up while I was talking. This is how simple the actual pipeline is. So again, as I was saying, I'm only synthesizing the actual deploy stack. So I'm synthesizing itself for the mutation step. So the mutation step, this is a standard step. The only change that I've done to this step is specify the stack instead of synthesize all. Then on top of that, I've added the control, the tenant control stage. So as I said, we're adding a stage to the existing step. What that's going to go and do is go back to my diagram, is just deploy the control stack. So now in this case, it's simple. It's an API. It's an API gateway and a Lambda, which is my control stack. I have my Lambda. Again, I have some additional policy updates that I need to make for allowing my build server to execute. Was it the project?
Aaron, can you zoom in a bit? It's hard to read.
Oh yeah,
You command plus, you know, for those.
Yeah, I was doing the this. I used to be able to do command scroll, and it would update the code, update the size. All right, so creating my Lambda, I'm adding the ability to actually execute the build server from the Lambda. And then obviously I want to talk to the parameter store for putting parameters. So this is not just getting, but putting parameters. And then essentially all I'm doing is I'm saying, well, it's a REST API talking to a Lambda. So it's essentially a Lambda proxy. So it will take, the Lambda will handle what the input from the API post is. That's it. It's really simple. So that has zoomed everything. So that is just focusing on this guy here. So that's an administrative task. So you could either have a admin page in your application that allows you to do a sign up, and part of that sign up is going through a form and setting the name of the organization or whatever it is. And then it will go and execute and go and build out the resources. And then you may have a WebSocket back here that says, all right, that's gone and complete. Now click here to log in. And so then you go over to the actual application over here, and that's where you can now start to actually log in. And obviously the API key that gets created, we don't want to have to hand that off to them. You know, here's your key. It would be saved in the front end application as, now in this session, every time I make a request, I'm just going to use this key. So they don't need to be aware of the key. You hold it in the session of the application at the front end. And then so the pipeline, next step, if we get back into the pipeline, is the additional. So this is where to be able to call the build server, if I were to just do a standard stage with the actual tenant resource build, then there's no build server to call, right? It's just the original build server. So I have to set up another build step as a code build step, which is essentially another build step or build server that says, all right, I'm going to have to take the artifact. So that artifact will be handed in from the Lambda or the location for the artifact. I'm going to have to go and do pretty much the same as I did for my first time, install CDK onto my build server because it's a fresh install any dependencies. And this time, instead of just synthesizing, I'm actually executing a deploy. So it's still doing the same thing. The actual deploy command, if you actually go into the open source code for how the synthesize and everything works, it's doing the deploy and everything for you. So because we want to actually deploy our own stack, that's exactly what we're doing here in the command pipeline. Is we're saying, go and do the deploy for this specific resource stack. Now, the resource stack, I've played with this in a few different ways. I tried doing a stack that did a loop on a nested stack. That didn't work. I need to figure out how nested stacks work in the same way in CDK as they did in CloudFormation templates. So what I've done is, the advantage of CDK is the concept of constructs, right? So instead of, let's jump into it now. Instead of the tenant resources all being in my resource stack, all I'm doing in my resource stack is saying, go and get the list of, go and get the list of tenants. And if there's a new tenant, or if there's, actually, no, I removed that logic. It's been a while since I looked at it. All it's doing here is it's cycling through every tenant. So what it's going to do is, when I hand in that tenant into the actual stack, because it's managed by CloudFormation, it's going to go through and evaluate every instance of that construct and say, well, I've already got a construct with that ID and that tenant name, so it's not going to create a change set. But it'll come across the new one we've just added and say, oh, there's none here. So the change set is now adding an additional set of resources to that stack under the new tenant name. So that's pretty much all we're doing, is we're cycling through the tenants and executing the create resource, which is this construct up here, the resource groups, using the where are we? Client API. Okay, so here again, I can demonstrate. So this is reading param. I'll show you writing params to the parameter store soon, but this is how easy it is to read parameters from the parameter store in SSM. Is all you're doing is you're importing the SSM library, and you're asking for either string or list parameter, and then you're doing a value lookup, and that's it. All you need to provide is the value of what you want to look up. So in this case, all of my tenants, so the tenant list is stored as a parameter. The reason, so this is, string parameter. Okay, I'm not using a list because why? String parameter value lookup. I think it is a list parameter. Because so when a parameter is stored as a list, it's stored as a comma separated value. So you can see I'm doing the split on the comma separated value to go and get the full list. The other one that I'm looking up is the tenant API. So that's this guy. That's the existing API, so that the ARN for that has been stored, so that we don't have to go and search in other places for it. It's just a lookup, get the tenant API, and hand that to every creation of the resource stack. And so the resource stack itself is go and create the API key. And okay, one important thing that I found here is there's two ways of creating an API key on an existing an API when you're interacting with existing resources. You can allow the server side to generate the key, or you can generate the key and hand it to the server side. Now, if you want to use that key, which I do, I want to store that key value across all of my parameters that I'm about to create. If I allow the server side to do that, at the moment, it doesn't know, because I'm using an L1 construct. By the time we get around to being able to handle this with an L2 construct, I'm talking with the CDK team. This is one of my PFRs that I've raised just to make sure that in the same way that we handle tokenization for other resources, I want to be able to get that key from the API key when I create it, and then resolve it later on, right? So in this case, it doesn't work with the L1 construct because we're creating the API key, and I need to tell it, if I want to use it, I need to tell it to go and get or create a key. So I'm just using a unique identifier function. And then I can take the value of that and store it in my my parameters. So this is writing a parameter. All we need to do is the same as reading from a parameter. We say this the SSM.string parameter, but instead of doing the static query on the lookup, now what we're saying is add the context for this stack. This is just a resource label that basically takes the name that I've handed in and appends it to the suffix param ID, so I can change the param, but I don't have to retype the name every time. So all you're doing is this is the context, this is the stack ID, and then this is the parameter. So as I said before, I'm creating my tenant/tenant ID. So whenever we query, that's the one that we're looking up. The value for that is just the actual key as well. So I'm storing the key value, because if I want to look up and get the value from that key, I can just say .value, and instead of getting it from the name. So it's just a little bit easier. The rest of them make sense. The rest of them are so /name, the key, the tenant key /name, and I'm handing in the tenant name. The there's a couple of different checks, so you can now start to add your logic around what kind of resources you want to create, why you want to create them, what are, depending on what resources you're deploying. This is just a very simple, I've got one check around if I need the S3 bucket. Otherwise, if the S3 bucket already exists, then I'll use that. But in this case, let's just say I need the S3 bucket, so it's just doing a standard S3 create, and that's it. And then we're going and doing our DynamoDB create and our Cognito create. and then writing all of the arns to the parameter store, and that's it. That's the entire resource stack. So in the last few moments, I've got 10 minutes. Before I jump into the Lambda, do you guys want to point out, discuss, ask anything?
We were talking about cheese on the chat. I don't know how we got into that rabbit hole. But go ahead, Paul.
Just that somebody asked what linter you were using to try and make sure your code brackets end on the right column, end on the right line. You've got consistency between lines of code and so forth.
I think I have. It depends on which machine I'm sitting on. I think this one is prettier.
Okay, is that linting? That's what that's.
I think I know it's code. I'm pretty sure it's linting and code highlighting.
Okay, because yeah,
I'll have to double check.
I think some of the comments were around like maybe there was some inconsistencies there, so it was a trick question. Aaron.
So I'm probably not using a linter then.
Well, maybe. A formatter, right? Like if you go to line 34. So, yeah.
For those of you who, line 34 on which one?
Was it resource groups?
Yeah, this guy, line 34.
No, I think it was resource groups.
Line 34, this guy.
No, resource groups.ts in your constructs.
Oh, sorry. Line 34.
Yeah, here we go. So like you can see that like somehow you've got like double indentations here versus like lines 37 to 44. You've got like a single
closing bracket is in too far. I mean, we were just being like,
we're dazzling.
So actually,
we were just harassing.
Isn't this one the one? Oh, it's not. I was going to say, isn't this the one that's in the if statement? But you're right. Yep. Ooh, yeah, bad.
Yeah, and then sometimes single quotes versus double quotes, even though you're not using quotes inside of the quotation.
So
it's like quotation consistency.
By default, so used to using other languages, to me, a single quotation does something different to a double quotation. It handles the string differently. And then obviously in TypeScript and JavaScript, I'm not sure what this one's called. It's on the tilde key.
That one's that one's translation. The other one can be used either way in JavaScript.
Yeah, no, but if we scroll further down, where was it? I was nitpicking.
I've got a double quote.
You had double quotes in there somewhere, and I was like, oh, that's unusual. Like we've got a mixture of them. Like it depends on how you feel on the day.
It just reminds me of actually services like CodeGuru are good because you have a non-human reviewing your code.
Well, that's what I was going to say, right? So the double quote, my default is to use a single quote, but the double quote I found comes from my use of Code Whisperer. So I have a code hinter, which actually hints towards what I should write, and I've found that it's probably because every other programmer where it's learned from is using double quotes, right? So
like in Python, like when we go back to that, it's like double quotes are used if you've got like things that you're going to need to use a single quote for, like right, like to not break the string. So you'd use double quotes in those scenarios, whereas you might use single quotes for the majority of everything else.
Exactly.
Yeah.
Yeah. Exactly. All right. Where was I? Lambda. So this guy. So you don't need to see how the control stack. Everyone knows how to deploy a Lambda. Okay, so there's a couple of different things that I've been playing around with in terms of sending. I left the.
Here we go. Actually, 51 versus 55, or 52 versus 72.
Yeah, that'll be from my code hinter.
Oh, there we go. Okay, it's beautiful now.
See, I wouldn't actually name it that either. I'm not a big fan of doing all caps and underscoring. So yes, this has actually come from my code hinter. But that aside, it's my code. I should take ownership and clean it up. I've left the comments in here. Again, really bad developer practice for those who are new to starting out in development. When you're constantly doing commits, so CI/CD, your CI, you should be committing regularly, right? Every time you change a class, commit it. it doesn't have to commit to remote, but commit it locally at least, right? So you're having local commits. You might commit a couple of times to the remote a day, but you're committing every time you change a class or a major function, you go and do your commit, right? There is no need to have code that you don't use anymore commented out, because you can see it in your commit history, right? So if you need to go and get it, go back to your commit history, copy, paste, done. This just creates messy code. So for readability, remove your unneeded code comments. Use comments only for describing something in terms of what you need. It's required, so let's add that, or a comment at the beginning of a function to say what the function is doing, or something like that. But I've left that here to show you we can actually hand in environmental variables to the build server. So this is what we call this build is a build override, or a build environmental override. So instead of taking the environmental variables that are set up in the pipeline, I can now say, you know what, I don't want the environmental variables from the pipeline. I want to set up my own environmental variables, so override anything. And previously, I was setting the tenant name and a key, whether I need to do something true or false, as a environmental parameter. I then decided that I don't need to do that anymore, so I got rid of it. But I wanted to leave it here to show you that you can actually push environmental variables into a build server from the Lambda. So all we're doing here is, where are we? I'm using the SDK. So I'm using the code build client from the SDK, and then I'm actually just, the rest of this is getting my values from so remember I said we were searching inside the stack for a tenant in the tenant list. So we're adding that tenant to the tenant list, but we're doing a little bit of logic to say, does it already exist? Because maybe somebody's accidentally triggered this twice. So if it already exists in the list, don't add it, because the tenant already exists. So there's different places to handle that logic. At the moment, I'm handling it on this control plane Lambda, and then we're putting that parameter into the parameter store. Then all we're doing is we're creating our build manifest, or everything that we want to execute. And I'm looking at the wrong version of the code. So in this version of the code, I am specifying source type is code commit. So it's actually, this one is not cool, because this one's actually going to go and pull the actual the source code. Or artifacts. Yeah, it's going to go and pull the source code from code commit, which we don't want to do. We want to use the actual artifact override to specify the ID for the last for the artifact that gets created from the pipeline when it does the commit. So all we would have to do there is update the code ID. You can find that in the console. If you go into your pipeline, you can go and look at the outputs from your pipeline, from the build step in your pipeline, and go and look at the actual artifact that it creates. And it's the same ID. So you just add the ID in there, and then all we're doing is start build. So there is an actual start build function. We hand in the manifest that we've just created, and that's it. It's a super simple Lambda to go and execute what I would consider some complex workflow in order to create a resource stack based on a full pipeline stack. So we might want to go and add additional resources to this stack. We would do that by going and updating our CDK app and deploying it through our CI/CD pipeline. And then the next time somebody creates a new tenant, it's going to create those additional resources. But equally, because it's now managed in our stack, and our actual deploy is looking at the resource list and cycling through it, if I add a fourth resource to this stack, it's going to cycle through and go and add that fourth resource and update the parameter store with the API key for that fourth resource that I've added. So now I've got control over what is in my resource stack, and I'm giving a mechanism for being able to go and generate those stacks for every tenant that we add. Anyway.
Yep. So your state is persisted as the state of the infrastructure required to enable a multi-tenant is persisted in CloudFormation, versus, usually in the past you say like, these are the three resources we need to create when I'm onboarding somebody new. So you have this loop that goes over them, and then you're like, I need to offboard somebody. What do I do here? Like, you got to, this takes care of it all for you. We're over by a minute, Aaron, so we probably need to wrap up.
Oh, no worries. we'll end it there. Yeah. Reach out if you have any questions. You've got my handle. I'm happy to chat about further. Or yeah, thank you for listening. Thank you for chatting.
And we'll see you next week. And I'll probably say hello from Connecticut.
Awesome.
Nice, excellent. We'll see everyone next week and week after. Come join us for streaming at reInvent.
Hopefully see you there. Take care all. Bye.
Thanks everyone. Bye.